During a flight attendant walks down the aisle, reminding everyone to switch their phones to flight mode. Most people do it without thinking, some do it reluctantly, and to be honest, a few people don't do it at all. They just flip the screen face down and hope for the best, and nothing happens. The plane doesn't shake, no alarms go off, the pilot doesn't make an announcement. You land, turn your phone on, and life continues exactly as it was before. So what was the point? Does flight mode actually do anything? Or is it one of those rules that exists more out of habit than necessity? The honest answer lies somewhere in the middle, and to get there, one needs to understand what a phone is actually doing while sitting in your pocket at an altitude of 10,000 meters. Your phone is in constant communication, even if you aren't actively using it. It sends signals to cell towers, scans networks, and sends and receives small packets of data. This happens dozens of times per minute. It is essentially background noise. Your phone maintains its place in the network even when you aren't asking it to do anything. Here is the important part. When a plane is flying at cruising altitude, your phone cannot find a cell tower at the right angle. Ground stations are designed to broadcast horizontally toward other devices at ground level. When viewed from above, the geometry doesn't work the way it's supposed to. Therefore, your phone does what any device that can't find a signal does. It works harder. It increases its transmission power and begins scanning more aggressively in every direction, searching for anything it can connect to. In the early days of mobile phones, this aggressive scanning was a genuine cause for concern. The concern wasn't that a phone would bring down the plane. That was always an exaggeration. The more realistic concern was interference with the aircraft's communication and navigation systems. These systems operate on specific radio frequencies, and it was questioned whether a cabin full of phones broadcasting at high power could create enough background noise to affect the clarity of signals between the cockpit and the ground. Pilots reported hearing occasional strange sounds in their headsets that seemed to be related to passenger phone activity. It wasn't anything catastrophic, but it was real enough to be worth taking seriously. That was the origin of the rule, and for a long time, the logic of precaution seemed appropriate enough that no one objected too strongly. Especially at high altitudes, it is always better to be safe. But this is where things get more interesting. Aviation technology has advanced significantly since the days when these initial concerns were raised. Modern aircraft are built with much better shielding around their critical systems. The frequencies used by phones and those used by aircraft navigation and communication systems are sufficiently separated so that, while theoretically possible, interference has become increasingly unlikely in practice. Extensive testing has been conducted, and in most cases, no meaningful interference was detected. This raises the obvious question: if the risk is this low, why does the rule still exist? Part of the answer is regulatory inertia. Aviation rules, once established, are slow to change. The cost of being wrong is high enough that institutions lean heavily on the side of caution. Changing a long-standing safety rule requires extensive evidence and numerous tests involving coordination between multiple regulatory agencies in different countries. This process takes time, even if the underlying risk has largely diminished. But there is another reason that is often overlooked. It's not just about the plane, it's also about the phone networks on the ground. When a plane full of passengers passes over a city at high speed, every phone not in flight mode tries to connect to multiple cell towers simultaneously. It hops rapidly between them as the plane moves. This creates a kind of network congestion, a wave of connection requests hitting cell towers in rapid succession from an unusual angle and altitude. It's not dangerous, but it disrupts the network in a way that ground-level users can occasionally feel. So the rule exists for a series of reasons: a historical concern regarding cockpit interference that was real enough to be taken seriously, a regulatory structure that is slow by design, and a secondary effect on ground networks that no one talks much about but actually exists. So, what happens if you forget to switch to flight mode? Most likely, nothing noticeable happens. Your phone struggles to find a signal, consumes battery faster than usual from trying, and creates a small amount of radio noise that modern aircraft systems can easily handle. The flight proceeds normally. The pilot doesn't know. The other passengers don't know. But the slightly faster battery drain is real, and the fact that the risk has shrunk significantly doesn't mean it is exactly zero. It means it is small. At 10,000 meters, inside a metal tube moving at 900 kilometers per hour, this is still a reasonable place to draw a line. Flight mode ultimately costs you almost nothing, a 10-second inconvenience. And the reasons for its existence, while not as dramatic as the rule implies, are still reasons. If these kinds of questions, hidden within the daily instructions you've followed for years without asking why, interest you, most questions is exactly where they live. Subscribe, and let's keep asking.